We now turn our attention to equations that have more than one square root in them. The simplest of these is when we have a square root equal to a square root. It's pretty straightforward because we've satisfied the first condition, which is have one square root isolated on one side of the equation. In fact, we have that twice. So when we square both sides of this equation, we simply get 7x plus 5 equal to 8x plus 4. And then we just solve this linear equation. So subtracting 7x from both sides gives us x. Subtracting 4 from both sides gives us 1. Our potential solution is x equals 1. Let's see what happens when we plug it in on the left side. We get the square root of 12. When we plug 1 in on the right side, we get the square root of 12. They are equal to each other, so x equals 1 is a solution. Let's examine what happens when we have multiple square roots in an equation, but we also have a constant. Generally, this is going to mean that the algebra along the way is going to be slightly messier. So let's take a look. We do have one root isolated on the left side of the equal sign, so let's square both sides. So we're going to get x minus 7 equals 7 minus root x squared. Again, we don't get to just square each term. We have to take the whole right side of the equation and square it. So this gives us x minus 7 equals 49 minus 14 root x plus x. Right? When we FOIL this out, the last terms we're going to get are negative square root of x times negative square root of x, which will become positive x. Now when we simplify things, we're going to get negative 56 equals negative 14 root x. So we still have this square root floating around. Before, in our previous problems, when there was only one square root, when we squared both sides, all the square roots went away. Now we're still left with a square root that we have to deal with. However, in this case, if we divide both sides by negative 14, we're going to get 4 equals root x. So we square both sides of the equation, giving us 16 equals x. And I'll leave it to you to verify that this is indeed a solution by plugging 16 back into the original equation and verifying that it's true. And it is. So we get x equals 16 as a solution. Now let's consider the square root of x plus 2 plus the square root of x minus 1 equals 3. Well, we need to get one of these roots isolated by itself. So let's take the square root of x plus 2 and subtract the square root of x minus 1 from both sides, leaving us with 3 minus the square root of x minus 1. Now we'll square both sides, giving us x plus 2 equals, now we have to square the right side of this equation, so it's this whole piece squared, which means we're going to FOIL it out, giving us 9 minus 6 times the square root of x minus 1, and then we're going to get a plus x minus 1. This last piece comes from when we FOIL the last terms. We're going to get negative square root of x minus 1 times negative square root of x minus 1. A negative times a negative will give us a positive, and the square root of x minus 1 times the square root of x minus 1 will give us x minus 1. Right? If you don't quite see it, go through and FOIL this out. Multiply this thing times itself, FOIL all the terms out, and you should get this. Now we have an x appearing on both sides of this equation, so let's subtract x from both sides. And then we've got some different constants floating around, so let's round those all up to the same place. And we will get negative 6 equals negative 6 times the square root of x minus 1. Divide both sides by negative 6, we get 1 equals the square root of x minus 1. Squaring both sides of the equation gives us 1 equals x minus 1. Add 1 to both sides, x equals 2. If you take 2 and plug it into your original equation, we're going to get the square root of 4, which is 2, plus the square root of 1, which is 1. 2 plus 1 equals 3. It all works out. So x equals 2 is a solution to our original equation.